Okay, so welcome to the new channel. We're going to get things started here. We're going to do some development, we're going to do some programming. Currently I'm in my shed, and at the moment you can see behind me I've got some big screens, and they've currently got a whole bunch of work stuff on them, so they've got statuses and system statuses, a bit of security cameras. And in the evening I don't really want to show work stuff, I want to show some cool interactive things. So today I thought what we'll do is we'll get started and we'll build the first screen for this big screen on the left. Yep, that's the left hand one. And we'll just crack on and see how well that goes. So these are both running Raspberry Pis. There's a Raspberry Pi behind each one. I wanted two Raspberry Pis. I was running one on both, but it was basically just not going to handle the screen resolution I wanted to run at, or the frames I wanted to run at. So I've got one behind both. The one on the left actually had a bit more disk space than the one on the right, which is really there just as an output screen to run, the Chrome and things. What we're going to do is we're going to use a thing called Pygame. We're going to write this in Python. I'm going to take you through the thought processes right now as how this all gets put together. So the first thing we do is I basically have a broken down a backdrop which looks on this. I've blanked everything out here, how prepped I am. So the first thing I've done is I've saved all of these elements as a separate layer. So I have a folder full of lots of PNGs with lots of transparency on. I'm going to quickly bring up a Pygame framework because I'm going to use this going forwards. I'm going to adapt it going forwards. I'll put the link to this in the GitHub channel below. And then this will be the basis of the screen generation. I want to be running this around 15 frames a second, not because I know Pygame will push 40, 50, 60 frames a second, especially what we're doing here, but I don't really want to tax the Pi that fast. I'm not really going to be generating that many different frames. So I'm going to crack on now. I'm going to pause this for a second, move my windows around, set up a new project folder, and then we're going to crack. Alright, so here we are. We're at the beginning of this project. I'm sorry about the frame rate of my camera. I'm getting a new camera soon. This is because I want the angle to use this particular camera. So what we have here is a Python Explorer. I've started a folder. These are all the individual assets I said. They're all coded like there's the outline of the text in the middle, there's the upper left, and then there's upper right, lower left, lower right, and then the inner and the actual invalid entry logo that we have going on. So what we're going to do first of all is we're just going to start by instantiating the Pygame classes. I'm going to be running on this virtual env on this computer, and then I'll transfer it over to the Pi later on. So very basically, some people import it as PG. I like using Pygame as Pygame. The other one I'm going to need .time import clock. This is interesting for me. And then I'm going to want random as well. Now, the reason I want clock is I want to lock the frame rate, but I don't want to do it myself. I don't do other manually sleeping and things. 1920, and the height is going to be 1080p. So we're going straight for 1080p. We have to instantiate the clock. I only got introduced to the clock quite recently. Now, the next line, I'm only going to write half of it at the moment because I'm going to come back. If I write the full line, it gets a bit nasty. Right. And basically at this point, I'm just copying the basic setup of the width. Right. So this gets passed in as a tuple as the first argument, so there's double brackets there. This is basically how you set up a Pygame framework. I'm using Python 38, and I'm using a virtual env as well. I didn't want to go into the pros and cons of setting up Pygame. On a Mac, so I had to use a particular version of Pygame, otherwise it doesn't quite work right. Now, Pygame works basically by having a main loop. So I'm just going to set alive to being true. I'm going to come back to that in a moment. While alive, so this is now an infinite loop. For event in pygame.event.get. We're basically going to if event.type equals pygame.quit. That. Print by, and then we're going to do pygame.display.quit to quit nicely, and alive equals false. Now I like to do that. I also like to just shove this one in here because I've had problems when you go full screen, some of the problems closing things. If event.type equals pygame.key down, so any key is pressed, any key is pressed when pygame.display equals dot quit again, and then alive equals false. And then what I have to do here is make sure I go outside that for loop and do if alive, and this is where we're going to go into the basic framework. So the first thing I want to do every time is fill the screen with black. Now I'm going to use 4 zeros because I haven't actually set an alpha, but I want 3 zeros. 3 zeros should do. And that should fill it up nicely. And then the other thing that you always need is, I've been writing the languages. The other thing you need here is a pygame.display.flip. Now that will actually cause it to render in the background. Clock.tick. I want to run at 15 frames a second. And that basically is the main frame sorted. Okay, so that will tick over nicely. If I run that, if I save that and run that, run me, then you get the nice little printout, and unfortunately it goes onto a different screen. Now, Pygame Mac is a weird thing when you cross the screen, it doesn't work, so I'm just going to move that over there, run that, and it should actually run on the right screen now. I don't know why Pygame started doing that. I get a black screen, which is kind of what I expect, because I haven't imported anything in yet. I don't want to do this in the main loop, actually. I'm going to go back up here. And what I'm going to do is I'm going to have a bunch of assets in here. Okay? So each asset I want to load up, but I want it to load up back equals pygame.image.load asset stroke lightning stroke I think it's called ie-1.png. Okay? Now here we're just going to do screen.blit, it's called back, and I want it to go at 0, 0. Now by saving all these individually at the full size of the screen, yes, it's going to use up a little bit more memory. Don't really care, these Pis are stupid amounts of memory these days. So I'm going to blit that in, and it's going to blit the whole screen in. I'm going to do it on every frame. It's not going to be very expensive to do, and let's just check that works nicely. There you go, logo, middle of the screen, looking beautiful. Now, I've actually got some more things here. So I'm going to make this an array. And what I'm going to do is I'm just going to copy that 3 times. And these basically have inner 1. So it's just inner 1, inner 2, and inner 3. And all we're going to do here is do for I in range, I in, image in inner screen.lit back image 0, 0 like that, and then save that, give that a quick whirl. There you go, nice purple outline. Now I actually don't want just a static image. If I wanted a static image, I would have just compressed those to a single image. So let's do something a bit more fun. If random is greater than 0.09, which means each one has a 0.1 in 10 chance of not rendering. No, that's the wrong way around. If it's 0.1, okay. Also put semicolons in because Python does require it to work. Now we should get is occasionally we get a little bit of funkiness, and you see it's a different line each time that's rendering. Sometimes there's a chance actually all 3 won't render. So now we have a bit more dynamicness going on to this cool thing, and already this is beginning to be a little bit cool. Let's just do that again. Let's do this for the outer line now. If I was building something for work, the reason I want to do this channel is because at work I have to write very formally. All this I wouldn't be able to hard code this stuff. I'd have to go away and actually build like a JSON array, pass it in as a data object, actually build this properly, build unit tests for everything. It doesn't matter here, as long as it runs, that's all that matters here. So I'm going to do the same thing here. I'm going to actually go and put the same probability on this, but it's going to be outer, and there's going to be outer. Always good image again. Same probability. And there we have a really cool little, already looking quite cool on the display there. What I'm going to do is I'm going to see if I can throw that onto the screen behind me, and let's have a look at that. Okay, so on the Pi here, And what we're going to do is go into the big screen. I've already got my VMs up. I've already got all the libraries I need installed. I've got a few too many libraries because I use this for this screen. So it should be as simple as Python, run me, and what we have here appear just about works. You see it on the big screen behind me. Bit blurry, but it's definitely there. So what we're going to do now is we're going to get rid of, we're going to modify this code very, very subtly, okay? So just to check it works, I'm going to remember to come back later to this. Here, I actually want to pass in some more arguments. One of the things you can do is you can do flags, ooh, no you can't, equals, and this is pygame.fullScreen. The one complaint I do have about Pygame is that it puts all its static numbers into one place. But you know, so what it should do now is it should make it full screen, and that looks beautiful. We can now go back to working on. I'm just going to close that. I'm going to go back to working on the actual thing because I want to bring the lightning into effect now. So I'm going to call this upper left equals, and then just drag those three in again. And these ones I named very originally upper left, like that. Okay? Upper left 1, 2, 3. There we go. Those images there. Now these images I wanted to work a little bit differently. I wanted there to be, when the lightning, I don't want it just to appear for one frame. I want it to appear for 2 or 3 frames and maybe a bit longer, but still have a lot of random dynamicness to it. So I'm going to actually store it in here. I'm going to put a number, okay? And this is where this gets a bit more fun. So if upper left is equal to 0, random dot if random dot random is greater than 0.9. So there's a 10% chance of it going off. That feels a bit low. So remember, we're doing 15 frames a second. That means it's going to go off probably once a second. Probably a bit low. So I might make that 0.95 sort of thing. And then upper left equals random dot choice. And I'm going to choose between 0, I'm going to choose between 3, 5, and 7 frames. I picked those completely arbitrarily. They have no meaning to me. Now, what we're going to do with those is basically, if it's 0, we're not going to display. However, if it's not 0, we are going to display. But one thing I want to do is to introduce a little bit more randomness to it. And I want it to have randomness. Because else, on the second time round, if random, upper left equals random, plus equals, I want to add to it, random dot choice. 0, 0, 0, 0, 1, 2, 3, 4. Right? If upper left is greater than 0, upper left minus equals 1. So that's going to reduce that number by 1 every time. At this point, we're going to let in the lightning. So the other thing I want is I always want there to be at least 1 lightning. So the options, when there's 3 frames of lightning, I've got 3 strands of lightning for each one. The options are true, false, false, true, false, true, false, 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 true. That's 1 lightning strike each. And the next layer is if 1 to 2, so it's true, true, false, true, false, true, and finally false, true, true. And then the last one is just what is all 3 on there, true, true, true. So the only one we're missing really from the entire set is false, 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 with them all turned off. So I'm going to do this time equals random dot choice options. I do like random dot choice. It's one of my favourite little functions because you can stack the odds on it. You can make bell curves and things by hard coding in. To pick one of these, it's more likely to pick a 0 than it is to pick a 1. Well, it's the same amount probably to pick a 0 than a 4. So your average of it picking is somewhere in between. In fact, I can put another couple of zeros in there just to stack the odds to make it not always extend. So here we are. We're basically going to go for x in range. Yeah, that'll work. X in range 3. We're going to say if option if this time x, we're then going to say screen.blit upper left x 0 0. Okay, so basically we're going to use this as a little index to loop over all 3. It's going to go 0 1 2, and it's going to go 0 1 2 there as well. So if that's a true, then it will get blitted, and if it's not true, it won't. So this should give us a nice lightning style thing going on. See if that works. Boom, it exploded, and exploded because it takes 2 position arguments, but 11 were given because that should actually have been a set inside as the first argument, not lots of arguments. There we go. Okay, so the lightning's come on, and it isn't going off. That is awesome. So let's just have a look where I went wrong there. So we are doing upper left -1. I wonder if the number's going down. So I'm just going to print upper left off. I'm going to look at what goes on a little bit. So it's hovering, doesn't quite, gets quite high, gets to 10, goes back down again. So let's just put some, let's take that 4 out and put another couple of noughts in. That. See if we can bring that number down. And it's just playing with this number. There we go. There's a lightning strike. There's another lightning strike. Oh yeah. That's quite cool. Alright. So all we've got to do now is we've got to copy that. Now I don't want to copy that exactly because it's a bit of a pain. What we're going to do is we're just going to take out the entire section of this. I'm going to give it a print. We're going to refactor this code over here. We're going to call it here. Screen control images. And all that's actually too deep, so I've just got to go. Oh, no, don't do that. So the screen that we're passing in is the screen is going. The control will be this thing. So this is going to be control. This is the control flag that we're using, and we should really return that so that we know what it is. Images here is only used once. It's used there, so that should be nice. And then what we should be able to do now here is we should be able to do lightning. Upper left equals lightning. Screen upper left UL. So in theory, that should work exactly as it did work. Yeah. Oh, that was tense. Oh, that had me worried for a second. And now what we should be able to do is just copy that 4 times again. Technically, yeah, I can make an array of those things. I wouldn't have to separate them out. This is going to be upper right, UR, lower left, lower right, lower right, lower left. And then make sure that they go on that side and that they go on that side. And then lower left is naught, lower right, naught, upper. And that should give us 4. Oh dear. Didn't copy that three times. 1, 2, 3. That should be upper. That should be lower right, lower left, upper right, and then those will be upper right, upper right, upper right. These should be lower left, lower left, lower left, and these should be lower right, lower right, lower right. All right. Didn't save that. Save that. Run it again. And now what we should be able to get is little lightning strikes coming in 15 frames a second. Pretty cool. I'm going to leave it there. I'm going to stop recording now. Thank you very much. If you do like this, please hit like, please hit subscribe, and we'll see where we are in the next episode.